and thank you for joining us. So let me start in the introduction by saying that we in IT really understand today how to build business systems. We really have, I think, reached a point where that's kind of table stakes for IT today. It's what I call dial tone. Well, dial tone is not something that everybody on the phone is probably aware of these days, but nonetheless, it is really what we know how to do, and we know how to do it extremely well, and we can do it at a relatively low cost, and we can do it relatively quickly, and we use advanced technologies, including business rules technologies, to reduce time, reduce money, and to reduce risk. The problems, I think, in building business systems have been solved. They're going to get along. There are still significant problems, and where do the problems lie? The problems lie in the business's ability to discover, define, validate, and manage the business policies, the regulations, the operational decisions, what I call the business logic. They understand what it is that they want the system to do and when they want that system to do it, and how that system is going to comply with the ever more increasingly complex regulations and resultant business policies that we have to impose. That's where the problem lies today. That's the long pole in the tent. That's where the risk lies in building these systems. And the ability to actually express that logic in a form manner that IT can actually understand in order to convert it and to operationalize it into a system. So the ability to not only discover and formalize that logic, but express it in terms that is sufficiently clear and sufficiently understandable that IT can implement it. That is of the decision model. That's the role of such technologies as Sapiens Decision. And the decision model is a means for the business to actually understand how to express this logic, how to build this logic, how to validate the logic and test the logic to ensure that it is exactly what the business expects to happen when a system is going to be operationalized, and to be able to express it in a manner that is clear enough, understandable enough, but rigorous enough that it can be implemented in an operational system. So, value of the decision model. Well, let's look at a typical business strategy implementation life cycle. And this life cycle really exists whether or not we're doing an agile approach or a waterfall approach, but we think about typically the process for requirements formalization as the beginning of the discovery and analysis once we've actually done our scope. But today it's cumbersome and lengthy. It often produces ambiguous and incomplete requirements and slows down the delivery of new and changed products and services. And one of the biggest problems in the discovery and analysis for requirement formalization is that we really never know when we're done. We don't know when we have a complete set of requirements. So we really don't know, using existing methods of narrative and existing methods of presentation of requirements, when done is done. And then parts of organizations are going to take that logic and they're going to understand it differently. Because it is narrative form, because it is frequently and very frequently done in a language which can be interpreted in multiple different ways, different parts of the organization are going to understand that logic differently. So the peer review of requirements documents is complex. Documents are large, they're hard to understand, and frequently sign-off is not really indicative of actual logic verification. In fact, my experience in many projects that I have reviewed is that sign-off is a formality, and that sign-off does not necessarily indicate that what is being signed off is exactly what is required. And of course, the lengthier the document, the less likely sign-off is to have been correct. So not a living aspect of as-is logic. Root cause analysis, support questions, or compliance reviews require manual extraction of existing logic from applications. So have you ever experienced the need to audit a particular requirement from an existing system? How does that audit proceed? Very seldom can that audit go to the actual requirement document. Invariably, the audit then ends up by looking at the code. So, and the dependency is always on those few knowledgeable individuals, the sort of tribal knowledge of the system. Most implementation gaps are discovered only in testing, and many in UAT. And so frequently, business rules, which are one expression of requirements, are actually developed in UAT itself. And then missing defects result from this kind of operation, from this kind of approach, cause production errors, missed requirements, errors, just blatant errors, incorrect requirements, unintended consequences. One of the problems is that when we have change, when we are required to implement change, we can't simulate the impact of change. That results frequently in de-scoping of requirements due to the magnitude of effort to automate or to actually transform existing code. What are the negative consequences of this state of affairs? Firstly, lengthy requirements capture, a very high percentage of duplication of effort, because you're implementing some logic in one place, you're probably implementing that similar logic in another place within the organization, and so there's that duplication of effort. Sometimes it's almost impossible to determine how much duplication effort. Production issues or operational issues, missed requirements, errors, incorrect requirements, unintended consequences. And the cost of operational errors can be very extreme, ranging from very large fines for regulatory problems to, very large operational issues where systems close down or incorrect filings are created or incorrect customer interactions occur. And then very large amounts of effort to correct implementation issues found in UAT, because when errors are found in UAT, the cost of repairing that is 10 times the cost of actually producing the correct requirement in the first place. And then manual extraction of existing logic from applications. Whenever applications need to be changed, the lack of traceability from requirements to the actual implementation of those requirements means that the logic has to be extracted manually with a very error-prone process. And, of course, the de-scoping of automation, meaning that we don't achieve our goals in the first place. So all of this results in slow, late time to market, high cost of error detection and resolution in day-to-day operations, escalating costs and compliance failures, and this brings risk to the business. In a decision-aware process, a process where we do have decisions, we see a collapse of the cycle, a very dramatic collapse of the cycle, because we're able to discover and review, verify, and test our logic at the time of discovery, at the time of analysis, and it leads to the opportunities to auto-transform those decisions into code and go straight to UAT. That collapse of cycles leads to instead of a vicious circle, it leads to a cycle of ever-improving productivity and ever-improving control of the business.